So the first four terms of a pattern are shown, and I've drawn the next term just before I started here. This one here, just add 5 down at the bottom, it's fairly straightforward. Then we're asked to count the number of dots in each and write these as a sequence of numbers. So our sequence is 1, then we have 3, and then we're adding 3, so we're going to have 6, then we're adding 4, we're going to have 10, then we're adding 5, we're going to have 15. Is it quadratic, linear, or cubic? Well, let's look at our differences. 2, 3, 4, and 5. And the second difference is 1, 1, 1. So the second difference is the same. Always write it down. Second difference is the same, so this sequence is quadratic. Noting that the nth term of the pattern will have 1 plus 2 plus 3 plus 4 plus n dots, use this formula. Sn is equal to n over 2 times 2a plus n minus 1 times d to find an expression for the number of dots in the nth pattern. So we want nth pattern, so we're going to have n in our answer. So we need to fill in what a is and what the common difference is. So a is 1, the first term, and the common difference. So let's fill these in. We're going to have n over 2 times 2 times the first number, and d is the common difference, so it's going to be plus n minus 1 times the common difference, which is 1. Simplifying this, we're going to get n over 2 times 2 plus n minus 1, which is n over 2 times n plus 1, which, what way did we want to do it? So it's going to be n squared over 2 plus n over 2. And if we check this, we check maybe the fifth term, we have 15. So if we put 5 in for n, we're going to get 25 over 2 plus 5 over 2, which is 12.5 plus 2.5, which is equal to 15. So we can see here that we're correct. Always check your answer, if possible. Question 4, we're asked to draw the next stage of the pattern. So there's so many different ways to visualize these. For me, this is one short of a 2 by 2. This is one short of a 3 by 3. This is one short of a 4 by 4. So if we draw 5 by 5, we just take that last one out. You guys will measure this in an exam, make sure you have it perfect. This is a bit rough from me, trying to do a 5 by 5. And then what I'm going to do is just, if I had a rubber, I would rub this square out so this doesn't exist here. I can't do that, it'll rub out the whole line. So that's my T4. So the number of little squares in each pattern form a sequence, U1, U2, U3, U4. Write down the first 5 terms. Well, you can ask this question in many ways. Basically, how many squares are there? 3. 1 short of 3 by 3 will be 8. 1 short of 4 by 4. And 1 short of 5 by 5 will be 24. Is the sequence linear, quadratic, or cubic? Well, let's have a look. It's square boxes, it should be quadratic here, so we have a difference of 5, 7, 9. Second difference is the same as 2. So therefore, it's quadratic. And I'm going to get you to write down a consistent reason why. So you could say second difference is the same or a non-zero. Second difference, same. If 0 is the second difference, it will be not quadratic, it'd be linear. So find the value of U7. So we could keep going. T1 is 2 by 2, say minus 1. T2 is 3 by 3. So T7, you can see 3, 1 more than 2, it's going to be 8 by 8, 64 minus 1. So there's going to be 63 blocks in it, or 8 squared minus 1, or n plus 1 squared minus 1, which we multiply out will be n squared plus 2n plus 1 minus 1, or n squared plus 2n. And we put in 7, we're going to get 7 squared plus 2 7s, 14, 49 and 14 is 63. which is what we got over here. So we can check our answer and see that we're correct.